All right. So the law of cosines is this. If I'm looking for angle A or side A, then A squared equals B squared plus C squared minus 2BC cosine of alpha. If I'm looking for side B, then B squared is alone on this side, and it's A squared plus C squared minus 2AC cosine of beta. And if I'm looking for C, then it's C squared equals A squared plus B squared minus 2AB cosine of gamma. All right. Those are the three. Law of cosines. Now, when do you use law of cosines? Well, when we don't have opposites. When don't we have opposites? Well, when we have side, side, side. So if this is like 16, 18, and 20, I don't have any opposites. So there's no way I can use law of sines. Okay? Also, when I have side, angle, side. When I have side, angle, side, I don't have opposites. I have nothing opposite. So when you have nothing opposite, you have to do the law of cosines. Now, if you're trying to find a side, law of cosines is super easy. You just type it into your calculator, take the square root, boom, you're done. So in a side angle side situation, oh, easy peasy lemon squeezy. Side, 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 there's a lot of math involved. There's a lot of algebra involved. And you can't screw up on your algebra or else you're not going to get the right answers. So let's look at this. So we'll start out with an easy one. We'll start out with a side angle side one, where A is 9, C is 14, and beta is 99.5. Okay, so what are we looking for? What's the first thing that they ask us for? Side B. Okay? If you have angle beta, or if you're looking for side B, you want to use the law of sines that has B squared. Okay? Make sense? So B squared equals the other 2 squared minus 2 times the other 2 times the cosine of the angle. So B squared is going to equal 9 squared plus 14 squared minus 2 times 9 times 14 cosine of 99.5 degrees. So I'm going to grab my calculator and I'm going to type it in exactly the way I've written out. So I'm going to go 9 squared plus 14 squared. Notice how I'm not hitting equals at any time here. Minus 2 parentheses, 9 parentheses, 14 parentheses, cosine of 99.5. Okay, I typed it in exactly the way it's written there. And I hit equals. Now, B squared will equal 318.59. That's an awful long side, 318 for this side. Can the triangle be that long on that side? No, because that's what B squared is. We don't want to know what B squared is. We want to know what B is. So then on your calculator, you just take the square root of it. Second square root of the answer. And 17.8. Oh, they want 4 decimal places. 17.8491. Okay, that's what B is. Now that we have B, then to find any of my other angles or any of my other sides, well, any of my other angles because I have all my sides, then I'll use law of sines. Okay, so I'll just go sine of 99 over its opposite side, 17.8491, equals the sine of alpha over 9. Now, could I use law of cosines here? I could, but it's a lot more work than what you need to do. So let's just use law of sines. Okay? So then I'd go 9 times the sine of 99.5 equals divided by 17.8491, and that's what the sine of alpha equals. So if I go second sine of my answer, I get my angle, 29.8. And if alpha is 29.8, then I take 180 minus 29.8 minus 99.5 is 50.7. Now I found every side, every angle. Okay? That's law of cosines. And then once you do get the side, then it's law of sines to find the other angle. Okay? It's pretty easy. All right. Side, side, side. This is where the work comes in. 22.7, 15.5, 18.6. Okay. So, what am I looking for? Well, I'm looking for angle alpha. So what goes on its own side? A does. So a squared equals b squared plus c squared minus 2bc cosine of alpha. Well, bless you, bless you, bless you, bless you, and bless you again. All right, so when we fill in the numbers, 22.7 squared equals 15.5 squared plus 18.6 squared minus 2 times 15.5 times 18.6 cosine of alpha. So basically what I have to do is I have to get this alpha by itself on one side. So like I say, there's a lot of math to do. So to do this, what we have to do is take 22.7 squared which is 515.29, 15.5 squared, which is 240.25, plus 18.6 squared, 345.96, minus 2 times 15.5 times 18.6 equals 576.6 cosine of alpha. Now, can I just take this plus this minus this? The answer is not quite. Because if we had 6 equals 3 plus 4 minus 5x, do we take 3 plus 4 minus 5? And the answer is no. We take 6 equals 3 plus 4 is 7 minus 5x. Then we move the 7 over. Negative 1 equals negative 5x. And we divide by negative 5, right? X equals 1/5. That's how you solve it if you just have numbers and variables. This is basically the same thing. So we can add these two. So 515.29 equals 586.21 minus 576.6 cosine of alpha. And it is so tempting to just take this minus this to get like 10 point something. But we can't do that because we're multiplying here. And order of operations doesn't allow us to do that. We have to subtract and then divide. So we have to subtract 586.21 on each side. So 515.29 minus 586.21 equals negative 70.92 equals negative 576.6 cosine of alpha divided by negative 576.6 is that. And then you take inverse cosine of the answer. And finally, we get our angle of 82.9. That took a little bit. Now, the super geniuses in here will say, hey, is there an easier way to do that? Well, super geniuses, there might be. Okay? If we have a squared equals b squared plus c squared minus 2bc cosine of alpha, and I want to get alpha alone right away, what can I do with these two? Well, if we move them to the other side, we're doing what with them? Subtracting them. So it's really a squared minus b squared and then minus c squared, right? Equals negative 2bc cosine of alpha, right? So we subtract those all across. Then, to get cosine alone, what do we have to do with this negative 2bc? What? Divide it. Divide by negative 2bc. And then, so I have a squared minus b squared minus c squared all over negative 2bc, right? Equals cosine of alpha. How do I get alpha along? What did we do in that last step? We did the inverse cosine. So when we move cosine to this side, it becomes the inverse cosine. So it's really the inverse cosine of that. And when you're working with the calculator, you put parentheses around that and that, then everything works out pretty smooth. Okay? So, what? You like this way better? Okay, that is just fine. But what you can do is this can go straight into the calculator then, if you do it this way. Okay? or else you can write it out and work the math backwards. Okay? Now, how do we get b? Well, that's just the law of sines. It's the sine of beta over 15.5 equals the sine of 82.9 over 22.7. So it's really fairly simple. It's what you were doing the last couple class periods. 15.5 times the sine of 82.9 divided by 22.7 inverse sine of the answer 42.7. So then we'd be left with 34.4 for that one, I think. Okay? So that's the basics of doing it. Let's do one. Oh. Let's just go with easy numbers once. Let's make it 2. No, not 2. Let's make it 12, 8, and 6. Okay, let's make it 12, 8, and 6 and do it once, just because they're easy numbers. So if we want to find alpha, then 12 squared would equal 6 squared plus 8 squared minus 2 times 6 times 8 cosine of alpha, right? So if I wanted to, on my calculator, I take this minus that and then divided by this. So I'm going to do that on my calculator once. Okay? I'm going to go inverse cosine, and it puts a parenthesis in there, but we got to put a second parenthesis in there for the top. Okay? So it's going to be inverse cosine, parentheses, and then we're going to put a parenthesis around the top and go 12 squared minus 6 squared minus 8 squared. Put a parenthesis divided by, and then parenthesis negative 2 times 6 times 8 close it. So I'm going to go 12 squared minus 6 squared minus 8 squared. Top is done now. So divided by parenthesis negative 2 times 6 times 8. Close that parenthesis and close the big old parenthesis in the end. If you do that, it'll instantly give you your angle. So 117.3, I think it was. Yep, 117.3. So there's less algebra this way, but you got to remember yet another formula. So, okay, whichever way you want to do it. And then you use law of sines to figure out the other ones. Okay, so we're good there. Okay, on the last few problems, it'll say, how many triangles have these parts? Okay, so if you kind of sketch them out a little bit, B is 2, that's 17 degrees beta. A is 5 alpha. So then C is here, or C is here, and this is gamma up here. Now, if you have this situation, you could possibly have, you definitely looks like you'll have one triangle like this. Could you possibly have one that looks like this, an obtuse triangle? Well, to figure that out, you have to use the law of sines to figure out if this makes any sense, or if this would be too big of an angle to make a second triangle. Okay? Now, can you have a 30, 40, 80 triangle? What's 30 plus 40 plus 80? 150. So this would be 0 triangles here. Okay? And then you just go through these and figure them out. And then when you get down to these, if this is 2.8 and this is 4.4, that means this is 4.4 because all circles have the same radius. So that makes this side 7.2. If this is 4.4 and this is 5.2, that makes this 5.2. So this side here is 9.6. If this is 2.8, this is 2.8, which makes this side 8.0. Once you have 3 sides with that, then you can start figuring out the angles. Okay, but that's the first step of that one. And then this one, you have streets that intersect like this. So this, I think, is 108. BC is 1.4. AC is 0.5. You have to figure out angle A here and angle B here because this is angle C. You have to figure out how long this is from A to B. Well, that's just simple law of cosines. Okay? So, you have 10 problems. It will take you a while to do